Dear students, in this video lecture, we are continuing our discussion about first order logic, and that is how to use first order logic to give knowledge to the computer and how to take knowledge from the computer. This is called assertion and queries in first order logic. What is assertion? Giving the knowledge, that is called knowledge base to the computer. The sentences are added to knowledge base using tell. Tell is nothing but assertion, that is I am dictating or I am giving knowledge to the computer. Such sentences are called assertion. I will ask the computer, tell me what is this answer, then through knowledge base it will try to answer. When I ask, I use the word ask, that is called query. Okay, so we call this as assertion and query. For example, John is a king. You should know. Richard is a person. You should also know. All kings are person. Okay, remember, all kings are person. Very long back in the diagram we discussed. Any human being is any king is a human being. Okay, all kings are person. Now my question is, what and all I am giving? Three statements I am giving. Remember, John is a king. Richard is a person. All kings are person. Now I am going to ask you one question. Is it Richard is a person? Yes, sir. Is it John is a person? Don't say no, sir. Don't say John is a king, sir. John is not a person, sir. It will be very stupid because you are having reasoning. Now I am going to teach this to computer. Computer also should have a reasoning. What is that reasoning? Is it John is a person? Obviously no. Why? John is a king. Kings are person. Obviously John is a king. King are person. Therefore John is a person. Okay, remember that. Now I am going to tell KB. Okay, that is knowledge base. Tell to knowledge base, John is a king. Done. Tell to knowledge base, Richard is a person. Done. Tell to knowledge base, all kings are person. Can you remember? All. Don't use the word all. Kings are person. Okay. Now what is that I am going to use? X is a person. Then X is a king. Okay, that is what the meaning. Now let us read. For all X, if X is a king, then X is a person. What does that indicate? Whoever is king, he should be a person. I am teaching to computer. I am telling to KB, whoever is a king, he is a person. But already what I told, John is a king. This all I am using the word tell to give assertion, knowledge to the computer, so knowledge base is updated. This is called assertion. Now I am going to ask a question called query. How I should ask query? Using ask. Ask knowledge base. Ask knowledge base. Is it John is a king? Question mark, because I am asking. Is it John is a king? Because I am using question mark. Query. Is it John is a king? Is it John is a king? Definitely it will tell yes. Yes, it will tell true. Reason. Knowledge base says it is a true. Next question. Careful. Ask KB. Is it John is a person? I told already. Is it John is a person? Sir, John is a king, don't say. Definitely John is a person because all kings are person. John is a king. Obviously John is a person. This statement says very clearly. Okay. John is a king. Kings are X. X is a person. Okay. So definitely it is also true. John is a king and all kings are person. Ask variable. Ask variable to knowledge base, who is X? Because X is a person, you know. Who is X? Don't think it will tell Richard is a person. Because computer also knows John is a person. Because John is a king, kings are person. If I ask who is X, computer knows X is John as well as X is Richard. It will tell both answer. X is John and X is Richard. Okay, this is called assertion and queries. We'll have some more relationship called kinship between the family kinship. Okay, one of the important topic, definitely you can face this in examination. One's mother is one's female parent. Anybody will have a parent. One will be a male, appa, father. One will be a female, mother. Now, once a female parent, obviously mother. I want to make it as a statement. M, you recall, M is a variable, but you recall it is a mother. C is nothing but child. Now, how to do? And both are statement. M is a female, and that female is parent of child. That is female parent of child. Now, C is a mother. C is mother. C is mother equal to M. Now, what is that statement? It's a biconditional statement. This is also true, this is also true. For all M and for all C, for all M and all C, C's mother is M and M is a female and M's parent is C. Okay, M is a parent of C. It's a complicated, but we use this type of statement in a family relationship. Male and female are disjoint category. What do you mean by disjoint? If a person is a male, he can't be a female. If a person is a female, he can't be a male. That's what the meaning. Okay, how to represent? If one is a male, he cannot be a female. No, negation. If X is not a female, X is not a female, obviously then X is a male. Okay, X is a male. That's what we are using. Both are correct, If this condition satisfies this condition satisfies. This is called biconditional. Okay, remember. X is a male, biconditional, if and only if X is not a female. Parent and child are inverse relation. One person is father for some other child, and obviously that child is baby of that father. Okay, how to represent? C is child of parent P. P is parent of child. Both are valid, biconditional. For all P and C, if and only if, whenever you use biconditional, if and only if P is parent of C and C is child of P. Something else we will use, something like numbers. We always represent natural numbers, 1, 2, 3, 4, 5, 6. Natural numbers as nat num. You can also use any other language, just a symbolic representation. Next is called successor. Before is called predecessor. I am going to use the word X, which is called successor. Using this nat num and S, we will frame some statements. Now, what is the statement? For all n implies, therefore, if, then. Come on. For all n, if n is a natural number, then successor of n is also a natural number. Okay, that is the meaning. N's successor is a natural number. If you say 5 is a natural number, its successor is 6, it is also a natural number. For all n, if n is a natural number, then n's successor is also natural number. We'll see one more. Little bit complicated, but a simple max. Can you do one thing? 0 plus m equal to m. Simple, 0 plus m equal to m. Provided if m is a natural number. That's what we are telling to say. For all m, if m is a natural number, then 0 plus m equal to m. Simple. Let us do the same work here. Sometimes people will get doubt in this statement. M's successor plus n is equal to m plus n's successor. Maybe confusion, but simple max. Let us take m is 4 and n is 6. Now you should tell me, what is m's successor? M's successor, who is next to 4? 5. That number plus 6. Okay, 5 plus 6 equal to 11. Remember, this term is 11. This term is also 11. Come on. What is m? 4. What is n? 6. M plus n, 4 plus 6, 10. What is successor of 10? 11. 11 equal to 11. So let us not bother about this max. Come here. For all m and n, if m is a natural number and n is a natural number, then m's successor plus n is equal to m plus n's successor. Okay, that's what we are telling. For all m and n, if m is a natural number and n is a natural number, then m's successor, everything I discussed. The same concept like query, tell, assertion and query, I am going to use this in the Wimpus world. Okay, what is that Wimpus world? When I stand at 1, 1, that is the agent, will I receive any signal? No, sir. No breeze, no stench, none, 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 none. Okay, obviously you know. At 1, 1, we receive this. Okay, anyhow, you know this. Then I moved to 2, 1. At 2, 1, I am receiving breeze. Okay, none, breeze, none, none, none. Information received at 2, 1. Anyhow, you know this. Now, how I should say, for all yes, okay, whenever there is a breeze, its adjacent will be pit, you know, that's what we are telling to say. Its adjacent will be pit. For all yes, biconditional. Yes is breezy. Okay, yes is a location. Okay, yes is breezy. If and only if its adjacent is a pit. If and only if there exists R is adjacent to S and R is a pit. Okay, that's what the statement. At one place, that is 2, 3, what we have? Stench, breeze, glitter, none, none. Stench, breeze, glitter, none, none percepts at 2, 3. If that is the case, what is the actions we will do? What are the various actions in Wimpus world? You can go right, you can go left, you can go forward. If there is an arrow and Wimpus, you can shoot. If there is a gold, we can grab. If you are at 1, 1, you can claim. Right now, I am not at 1, 1, I am at 2, 3. At 2, 3, what you are having? Glitter. Glitter means what? Gold. What I should do? Grab. Now I am asking, agent program executes the query. Ask the variable who is A. A is action. A is the best action. There exists A. There exists A. A is the best action at 2, 3. Who is the best action we are having? Because you received glitter, sir, obviously grab. Okay, A is nothing but grab. Okay, this is the story we are having. So what we understood, using that tell and ask, we can ask what is the variable and automatically it will tell glitter is there. It is a sensor, so you should know what work you should do. It is nothing but grab. Everything computer knows by using this particular technique. With this, I would like to complete this particular video. Let us see in the next video. Thank you.